Welcome to the demonstration of the Radiant Technologies Magneto-Electric test suite. What was delivered with the suite was a technical amplifier, a current amplifier similar to this model, but this is an older model, a Radiant precision tester, a Lakeshore Gauss meter with its detection wand, a Radiant current sensor, Helmholtz coil, a Radiant sample holder, and of course the requisite software that is associated with the Vision program that controls the Radiant tester. In order to set up the experiment, we were going to, what happens here is that the Radiant tester provides a voltage. It stimulates current out into the Helmholtz coil, which in turn stimulates a field. When we make our measurement, we're very concerned with knowing exactly what that field is. The Lakeshore Gauss meter will directly read the field. The problem is that the Gauss meter cannot, the wand cannot be in place during the measurement, so the Gauss meter needs to be removed from the experiment. So we're going to start with a calibration experiment in which we're going to measure the current into the Helmholtz coil and relate it directly to the field that we measure over a series of stepped currents induced by step voltages. What that's going to do is allow us to build a confidence that by knowing the current in, we can accurately predict the field out, and then we can measure the current in during the actual measurement, remove the Gauss meter from the measurement, and still be able to accurately predict the field that we're applying. In order to set this up, we're going to first ensure that the PC15 connector is attached to the rear panel of the current amplifier. Then we're going to set the voltage switch off. We're going to set the current switch off. We're going to put the mode switch into the current position. Then I'm going to connect a BNC to banana adapter into the current programming input of the amplifier. The adapter has to go ground plug to ground, and so that the tabbed portion of the connector goes to the black connector at the amplifier. Then we connect the output, the voltage drive output of the current of the precision tester into the current programming input of the amplifier. At the amplifier, we ensure that the ground and the common plugs, the green and the black plugs, are jumpered together. The amplifier was shipped this way from Radiant Technologies. The next, using a banana to banana, we take the output of the amplifier into the red input of the current sensor. We take the black output of the current sensor into the red input of the Helmholtz coil, and then we're going to take and complete the circuit by taking a banana connector from the black output of the current of the Helmholtz coil back into the ground of the current amplifier. It completes the circuit. At the rear panel, I'm going to take both of these here. At the rear panel, I'm going to first connect the ground plug of the current sensor into the green ground plug of the tester. Then we take the output of the current sensor, and not the sync port, the output port, into the sensor 1 port of the tester. And that completes the configuration of the current signal path. The next thing we need to do is connect the Gauss meter up. The Gauss meter sensor wand is connected into the probe input at the rear panel of the actual Gauss meter controller box. Then, with the connector that was provided, we take the aux IO port of the rear panel of the Gauss meter box. The BNC end goes into the sensor 2 port of the tester. Finally, to make the measurement, I need to insert the wand into the Helmholtz coil to detect the exact current, the exact field being generated by the input current. When I insert the wand, first of all, I make sure that it's vertically and horizontally centered within the coil, and I also make sure that the face of the detection surface of the wand is perpendicular to the direction of the field, which is through the center of both coils. Okay. Now at this point, I would run my calibration task within Vision, and perform a series of stepped voltages into the current amplifier, stepped currents into the Helmholtz coil stepped fields that I'm detecting, and then I compare the currents to the field and build confidence that I can predict that field. Okay. Now, in order to make the measurement, we're going to completely remove the Gauss meter from the experiment. Disconnect the I/O from sensor 2 and get it completely out of my way. Remove the controller. It's plugged in still. Okay. In place of the which way is best to go? In place of the sensor probe, I'm going to insert it into the sample holder. This is a prototype. It's a little different from the one that we ship. Basically, this connector is spring-loaded in the one that we ship. Here, it's nut tightened, and the SMA connectors are mounted directly and are female on the shipped model. The sample gets inserted into the sample holder between the top electrode, which is the spring-loaded contact, and the bottom electrode, which is a fixed copper contact connected to the SMA cables. The sample can be oriented rotationally in any as necessary, in any orientation that is necessary. Then the sample holder is closed, and the entire assembly is inserted into the Helmholtz coil. And this ensures that the sample is sitting along the center line of the field generation. Finally, from the SMA connectors on the sample holder, we connect the grounding plug that was provided to one of the connectors, and you would connect the opposite connector is the signal and response connector from the SMA plug to the return port of the tester, and so that the charge induced in the sample by the applied field is detected at the return port of the tester. And well, good luck.